All right, today we're going to pull back the curtain on artificial intelligence. We're not talking about the flashy models, but the really tough, behind-the-scenes work that makes it all possible. We're going to dig into what separates a truly powerful AI from one that just doesn't work. And here's a little secret. It pretty much all comes down to the data.
So you've probably seen this happen, right? You have a state-of-the-art model trained on mountains of data, and suddenly it spits out an answer that is just complete nonsense. People call it a hallucination. So what is going on here? How can these incredibly sophisticated systems get things so incredibly wrong?
Well, look, most of the time, the fault isn't actually with the algorithm or the fancy model architecture. The real root of the problem is the data it was fed in the first place. If you put in incomplete, inaccurate, or just plain messy data, you're going to get a mess on the other side. It's the oldest rule in engineering: garbage in, garbage out.
So to fix that garbage in problem, you need a really disciplined, systematic way to handle it. And that solution is a framework called Extract, Transform, and Load, or as you probably know it, ETL. This is the industrial strength process that engineers rely on to build data integrity before it gets anywhere near a model. And it's a super logical process when you think about it. First, you've got extract, which is just pulling in all the raw data from all its different sources. Then comes the most important part, transform. This is where you clean, standardize, and get that raw data ready for prime time. And finally, you load that now high-quality data into its destination, ready for an AI model to actually learn from it.
Now, every step here is absolutely essential. But that transform phase, that is the beating heart of data quality. This is where we take all that noisy, inconsistent raw data and basically forge it into a reliable, structured asset. It's where we apply really tough standards to stop errors from ever poisoning our AI systems down the line.
Okay, but what does good data even mean? What does it actually look like? Well, to answer that, data engineers use a framework built on 6 core dimensions of data quality. These are the principles, the actual standards, that we enforce during the transform stage to make sure the data is solid. So think of it like a quality control checklist for your data. It covers 6 key areas: completeness, uniqueness, timeliness, validity, accuracy, and consistency. You get all 6 of these right, and you've got high-quality data. So let's break down what each of these really means.
First up, completeness. This asks a really simple question. Is all the data you need actually there? For instance, if you have a ton of customer records, but you're missing addresses for an entire city, your data set is incomplete. And that's a big problem, because it can lead directly to sampling bias, where your model learns from a skewed version of reality.
Next, we have uniqueness. It's pretty simple. One customer, one record. That's it. If you have the same person or the same transaction listed multiple times, the model might think that one data point is way more important than it actually is. This is a classic cause of overfitting, and it'll wreck your model's ability to make good predictions on new data. Then there's timeliness. You have to ask, is the data fresh? I mean, an AI trained on market data from last year probably isn't going to do so well today, right? When a model's performance gets worse over time because its information is out of date, we call that model drift. Okay, next on our list is validity. This one's all about rules. Does your data stick to the defined format, type, or range it's supposed to? A perfect example is a probability score. By definition, it has to be a number between 0.0 and 1.0. If you get a value of, say, 2.5, that's invalid data, and it could completely break your model's logic. Now, let's talk accuracy. This is a big one. Does the data actually describe what happened in the real world? Little things like typos, a wrong product label, or swapping a couple of numbers might seem minor, but if the data the model is learning from is wrong, its predictions will be fundamentally flawed. It's as simple as that. And finally, we have consistency. This is all about making sure everything is uniform across all your different systems. Imagine one system uses a year, month, day format for dates, but another one uses day, month, year. It sounds trivial, doesn't it? But that tiny difference can crash an entire data pipeline, or even worse, cause the AI to interpret the same date as 2 totally different things. So, knowing these 6 principles is one thing, but how do you actually enforce them? Let's get our hands dirty and talk about the practical data cleansing techniques that engineers use to bring data up to these standards. And here's the toolkit. See how it all connects? We handle missing values to achieve completeness. We remove duplicates to ensure uniqueness. We standardize formats to enforce consistency and validity. And we hunt down and fix typos to guarantee accuracy. Every action maps directly back to one of those 6 dimensions we just walked through. Let's dive a little deeper into just one of these, handling missing values. You've really got two main moves here. The first is imputation. That's where you fill in the blanks with a calculated guess, like the average value. It's a great way to keep your dataset size intact. The other option is just removal. You delete the whole record. It's a cleaner method, but you only want to do it when you have a tiny amount of missing data, so you don't accidentally throw out something important.
So why are we obsessing over all of this? Why does it matter so much? Because all this careful, detailed work is what turns data from a potential disaster into a solid, reliable foundation. It's how you build AI systems that are trustworthy and actually perform well in the real world.
And it's really important to remember that this isn't just one thing. Effective data management is kind of the intersection of three different fields: data quality, which we've been focusing on, along with data integrity and data profiling. All three of these are totally intertwined, and together they form the absolute bedrock of any good AI system.
Ultimately, it all boils down to this powerful idea. The quality of your data isn't just some chore you do at the beginning. It is directly tied to how well your model is going to perform. Better data means a better model. It's that simple.
And that really brings us to the final critical question you have to ask yourself. As you're building your next AI solution, take a really hard look at your data. Are you building on a solid foundation, or are you sitting on a hidden liability, just waiting to break your next model? Because the answer to that question will define your success.